Hello, welcome back to our CSCI 430 operating system. And today, actually, we in the lecture we cover about related to process and kind of like before we move on. And later in the lecture, we'll cover about scheduling. And then when we talk about the multi-programming, multitasking. And we need to discuss one of the topic is how about manage multiple process using shared resources. And in the coming slides, I will give you some questions, like if I give in certain scenario, okay, if we have two processes or three processes, and then they require how many units of resources, then we need to write a pseudocode like function to determine like if they can grant the resources based on whether they're currently available. And later, of course, I will give you some exercise assignment to related to this similar topics. Okay, and before we move on, I would like to give you some the source code related to some like process and also related to the like the multi-programming multitasking sources. And then the first one I given you is the process. Okay, so if you look at it here, so you need to have some like header files importing the library. So you may check your system. If you don't have it, then you maybe need to download it. Okay, right here we need to have a standard like IO and also the unit standards or the weight library. I also attached the files, like the zip file, including all these like C++ file and then the weight the library. Okay, in case you don't have it, then you can add it, import it directly. So right here, if you remember in the lecture, we talk about like we have a system called it's called a fork function. So this one actually can help us like to create a child process. Okay, so right here is a really simple program. So we just checking, okay, so what's the PID? So if we remember, we have the process identifier, right? The process ID. So we're checking what's the process ID. So if this one, so if we don't have a PID, that means that okay, it fails. Okay, if we do have the PID, like say equals 0 is the child process with the what's the get PID function. So we try to use it to check what's the PID. And if we don't have any of it, then probably this one will be the parent process. Okay. So because like it should be working for all of your program. So this one, let me execute it and then I'll doing the output just like just call process. Okay, like this. Okay, so pretty easy, straightforward. So there's a one child. So you know why there's a reason why the child process like print out before the parent process, and then they do have a different process ID. So this one is the 18789. So it's like when the PID is like before it, but it print out after the child, because when we printing it, actually when we call the fork function, okay, right here, so we will checking. So actually we are execute, because if you remember, we have the last in first out, so we have the stack. Okay, so that's why when we fork them, if you remember in the in our lecture, that last part we cover, we talk about like after we have a system called either we have three ways, stay on the parent, switch to the child process, or switch to other process. And right here, the kind of like a good example is that we switch to the child process first. So that's why we print this message. After I finish, return, then we will print the parent one. So that's why we can get this one. Okay. And when later we have one is called the multiple process. So I would like to show you. So it's like kind of same way. So for here, I'm writing a loop. Okay, so you can check this time I'm using 3, and then I save it into a list. Okay, right here is array PID array, and then every time I call in the fork function. So that's why I calling the fork function, then I can create a new child. Okay, so every time I will print out what's the process ID. Okay, and using the get PID, this function, now it's leave 5 the time consuming task. Okay, this one is just simulate. Okay, if I'm waiting and come back. So after it finish, then I will print the ID message again. Okay, so every time when I call it, I execute it. And this time in the parent side, I will print out the parent process or child had finished, and that's it. Okay, so just waiting for all the process. Right here, you see I just like waiting for all the child they finish, then we will be okay because I already compile it. So I already compile this function. So I just call the MP. Okay, I execute it. So right here you see because the program executes pretty fast. So in the beginning we will the first fork. Let me do it in the left and right. So you can see. So the first child once we create, we have the process ID. So it's 18840, and then we will sleep. Okay, so we put in a sleep. Okay, and then the second one, the second child, and then 41. Okay, and then the third child will be 42. Okay, 0, 1, 2. Okay, and once they are finished, we will print the finished message. And you see the sequence because every time we create, then we'll print the sleep, and then because when they are sleeping, then we are waiting for the once they complete. Okay, so after the count life the time called like 5 seconds done, then we will print out there like in sequential order, finish the first child, second child, and then third child. And then later after you finish all this, then we'll go back to the parent process because you're waiting for all this creating, right? Waiting, and we will print out the message all child they finish. So here's kind of the idea like for multi-process. Then we will do it in this way. Okay, and you may try, we have one more. I give you one, it's called the multitasking. So when you open this one, and we are kind of like pretty similar. Okay, so it's like printing. So it's kind of like same. You can modify later and see what's the example, but it will be the same source code right here. So and if you need the wait function library, then you can change it. Okay, and here's the example we mentioned before. Okay, about the process. Okay, and right here just kind of the really basic beginning question. Okay, when we move on, if we have two processes, okay, P1 and P2, assuming if we have the resources, then you need to think. If we have P1 and P2, okay, but we have 1 unit of resources, okay, so who can get it first? And if just thinking, if P1 get the resources, then how can P2 get the resource again? Okay, so should I wait for that? Okay, and how can I check, make sure? Okay, there's no problem. Or like how can I see like what if this resources is available or not? Okay. So kind of like for your warm up, then I just showing you like how it's going to check. Okay. So normally we always giving a boolean. Okay. So this one is the global value. So it's showing the condition if this resource is available or not. Okay. So if I'm telling normally for this function, later you need to write a function like this because this one will be applied for it's like kind of like inherited from the process. If you remember, we create a child, right? So the child we need to have a function to checking can we grant the resource. Okay, so we're going to execute exactly same function in each child. So that's why when we open the files, and then for the multi-process, this one, okay. So you need to change it for multi adding. How can we add those functions? So right here, if you remember when we calling the function for the single process, like right here when we create a child, so we say if the PID equals to, so we are checking if there's a child or is a parent, right? But if we do have multiple child's process, so we are going to like execute this function exactly same code, and then they were checking the statement like right here instruction. Okay, so that's why we need to thinking in this way. It's like I need to have a pseudocode. Okay, it works on all the child, and then we can check it. So in the beginning, we are going to check if this resources is available or not, whether it's available or not. So maybe by the beginning, we will say the global is that the resources available is true, right? Because it's always available, okay? So in the beginning, we were going to check. So process 1 and 2, they will check if this resources is available or not. So if they do yes, return yes, then we can grant the resources to this process. Then we need to change this Boolean like to false. Okay, and we can return it. Okay, which process can it, because this one is just refer to P1 or P2. Okay, so if not, then we will return a message as a not available. Okay, so it's a really basic. So when you're thinking in two programs, let's say I have this two way. So if I create a new page right here, okay, right here, let me move a left or right and enlarge a little bit bigger. Okay, right here. Okay, so you see. So because we are thinking like in P1 and P2. Okay, so because P1 and P2, they do have exactly same function, okay, right here. So the exactly same function, okay. So I just quickly do it this way. Okay, so they have exactly same. So I will check if the resources available. So I'm checking this one. Okay, so assume if that one is true, then we can change the resource available to false. Okay, here's the first one, and then just like return. Okay, I just like skip this part. So if this one, if for the return, because we get the PID, so if we passing the P1, then we return the P1. Okay, so this time if we be passing the P2, then we will return the P2. Okay, so just make it simple. Okay, so P1 and P2. Okay, so what we're going to do, then you may ask a question if, because it doesn't matter, because like actually we don't know the order. Okay, when we doing the fork, either like the child 1 go first or child 2 go first, we don't know the order, just assuming. So if P1 execute the instruction, that means that this instruction, if R1, okay, so if R1, we execute P1 this instruction first, okay, checking if condition, okay, pass to the processor, okay, CPU handle it, the processor handle it, okay, so of course P1 check first, if we are executing in this way, because the statement doing it this way, okay, so if we, because right now the global value of the resources RA is true, right? So we know, okay, it's true. So when they check it, and because we are going to execute as a block, so we will turn to the available resources to false. Okay, so when we execute, after we change it to false and P function to process 2 and check this statement, okay, then it will see, okay, because it's already false, so they're not going to execute. Okay, so it will say, okay, resource not available. So here's the logic. Okay, so we do have identically same function because we are using fork. Okay, this system call. Okay, so we have a calculate identical function, but this time just like we're calling by different process. Okay, P1, P2, and P3, and we are getting the same unit. So this one we just using true or false to showing. Okay, there's a one. Later, if we're multiple, then we do have other way to show it. And this time it was showing so that's why I don't care either P1 or P2, but for this one we are going to check the resources available first if condition. Okay, so either one will grant the resources, and we will of course this one is not yet really perfect, because we need to release, right? So once you finish your, or like you need to return, then we need to release the resources. But this one just like for warm up to let you knowing, okay, as a beginning for P1 and P2, then how can we grant the resources based on like currently available. So if you have a type of idea, then we can move on for this time. Let's say we have the ABC, three sources type ABC, and then we have two processes, okay? And each process, they require the resources, and then the system need to ensure no deadlock occur. Later, you will why not just knowing the deadlock? Of course, later we have different other situation. We need to prevent it, and just I will give you a pseudocode how to solve it, and also sometimes we're using the while loop to check it. So if the request the resources, if they're available, so how we going to do? So we were doing the same. So we were going to check each of it and then looking for the resources. Is say okay, is our required resources is greater than the available resources. Okay, if one of them is a yes, that means we will return false because we cannot grant it. If yes, we are right, let's say like 5, 3, 2, ABC, right? But we just need 1, 2, 1. Okay, that means that probably process 1 can get it. So if we can request it, okay, pretty straightforward idea. Okay, so here we check. And if we have the scenario, say, okay, extend it because we need to simulate the allocation of resources to a process and check if it's in a safe state. Okay, one keyword is called the deadlock. Later we'll cover what's the safe state or like what's the deadlock, but why not here? So for the resources and then for the safety check, then we will like adding the kind of like for the while loop. So we always have a while true. So I will introduce this one. So we need to keep on checking. Okay, so keep on checking and then progress make and then false. And then we're checking like from this one. So from 0 to how many process. And then we were checking, okay, if they're not yet finished, okay, for this one. And then also what's like, can we allocate what's the maximum resource minus the allocate resources and based on how many work. Okay, if yes, then we can let it be finished. So we can make it. If no, then we cannot make it, then we just break it. And here's the idea. That means that for the OS, okay, if we have let's say we have certain amount of resources and then we have how many several process, okay. If we need to grant certain resources, we need to get it. And then the OS need to determine or like need to check do we have enough resources to allocate to this process? If yes, then we're going to do it. No, then we are not going to assign it. And then we say, okay, we can't, like we cannot afford that much resources. Okay, then we cannot like make the progress like as kind of two or like make it be finished it. Then we cannot complete it. So that's why this one is called safe check. Okay, so this one like safe check, safety check. And that's how can we prevent the deadlock too. So in case we don't because for the deadlock, that means we are asking for certain resources, but we never able to get it, or like we never know when. So that's why it's like we cause the deadlock. Okay, so this is kind of idea. Will I just go through it? If you cannot catch this idea, I will recommend you to take the source code and think about it. Okay, of course, I will spend more time like next time after the lecture, and then I also prepare extra work so we can discuss it one more time. And we have more right here. So if we go for safety check, right, after we execute this part, so we will keep kind of like going, we'll go and check, can we really allocate? So right here, so this one is the deadlock prevention. So you will see that if the requested resources is like more than our available, then we not going to assign. So it's return false. So we say, no, we are not allowed to assign. So that's why when we have let's say we have the list like the maximum resources and then already allocated resources, available resources like this, then we can show, okay, is it in the safe state? So we passing what's the available resources, how many allocate and then message. So we're going to check. So if yes, of course, we will say the system in a safe state. If no, it's not safe, then we are not going to take this action. Okay, aside. So in this function is safe. So we need to check. Okay, so there's a whole safe state doing, so always we have while loop always true. And if we can match it, yes, we can true it. Once you replug it, then it's like the progress always forward, you see. So when we say it's false, then we're not going to do it. Okay, either one of it like not finished, then we'll like because the finish always false. So either one of the content false, we are not going to say okay in a safe state. Okay, so it's the question. And one more, if we have a system with multiple processes and resources, then we need to have a pseudo function. Okay, so to apply the call the banker algorithm, but you are not yet learn it. So that's why we will come back for this part after I talk about the banker's algorithm to check new resources somehow. So I will just keep this part for later. Okay, so I will come back, and for the if you're interested, you can take a look about the four. Okay, solution is a pretty long solution to solve it. Okay, so if you want to check, you can feel free to say it because it's a lot. Okay, but it combines the deadlock, also the safety check. Okay, so you may, if you're interested, you can take a look. We are mainly thinking about like for the consideration. And kind of like based on this advanced, because this one we didn't have a complete solution, so I would like to let you later. So you need to have a complete the multitasking is that okay? So you try to gain the resources, right? Then you need to think about how can we release it. Okay, so if because we are executing process, right? Process one or process two, like a block by block. Okay, each block, right, we execute instruction. So either we until we finish it, then we will return from the function, right? Okay. So after we finish, maybe you need to right now we change to false, but once you're ready, then you need to change the resources to available back to true. Okay, so release it, and also you need to writing a for while loop program. Okay, so we need to like say have a while loop. Okay, so while loop we can put in the if the resource available like this, then we can keep checking. So these are for loop. Okay, so if say okay it's not yet it's false, then we just like waiting right here. So let's say because the if the resource available is false, then we check to put it as a true, then we keep like waiting in the while loop. Okay, and then I can copy this one and put it right here. Okay, so we have the while loop and keep on checking. So either process one or process two. Okay, I just assume because we don't know which process is going to be executed. Okay, as the first one. Okay, so just assuming in this way, and either one of them going to execute, then we will check the first condition is the resource available. Okay, in the beginning, right here, I put it as a global, so I put it on the top. Okay, it says a global variable because it's already saying, okay, we assume it's true in the beginning because nobody taken. Okay, in the beginning, initial time like time equals 0. Okay, so we're checking. So if true, and then the false condition, we're not going to stay in the while loop. Okay, so I assume like P1 execute first, then we can check. Okay, it's true. Then we turn the RA. Okay, so right here we're going to like executing certain function or actions. I just say actions right here or the functions. Okay, sometimes we're going to do. Okay, after we finish, we will release the resources, right? So when we release the resources, we turn it to true again. Okay, so when we execute the function for the P2 process 2, because we are right here. So in case that when we are switching the instruction, then we can avoid, okay, because when we going to in this stage, okay, we're going to call some function or action, we already took the resources. So the RA right now in this moment, let's say is already false. Even we execute the P2 in this statement, okay, while so okay, so why not the resource available, this resource is not available this time, so it will be true condition. So I'm keep like waiting in the loop. So I'm not going to execute anything really until I finish. Okay, I release it and then return. So the RA will be changed to true again. And then when the process 2, this function and check the results again, okay, this time it's true again, so it's become false, okay. Then I can execute for process 2's function. So this time I check if the condition is true. Okay, if the RA is true, then I will change the RA to false. So this time for P2 change to false, okay, then I can also execute certain function, okay, call function, whatever. So I don't know what we're going to do, some function. Okay, so after we finish, we need to change RA back to true. Okay, so that's your modification you need to do in this part. So making it, so later when we have process 3, 4, 5, then we will actually will be same. Even like getting the same identical source code, but it will be more safe. Like we are going to check. So we need to add the value to checking the condition. And if we do have available resources. Okay, so if assuming we need 2 resources like RA1 and RA2, okay, so maybe in the beginning we just assuming they are true, 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 then you just need to check RA2 and 1. Okay, so you need to make sure both of them they are available. Then you need to check it. This is condition and like this. Okay. So you need to modify in this way, and then we're going to check up RA1 and RA2. Okay. So we need to, of course, we need to change RA1 to false and then RA2 to false. Okay. After we execute certain function, taking certain function, and we need to change the RA1 to back to available true. Okay, so for the content right here, you see exactly the same. So we are not going to writing the function in like duplicate and then individually. So that's why when for our logic, okay, when we writing the program or like for this one, the prevention is like, how can how so many no matter how many for function I try to call, okay, so maybe I don't care how many child, okay, how many children, okay, this program creates or how many process we have, when we run in this identical function, okay, so we'll make sure like above them they're checking the resources, and based on the condition that we can taking to move on to the next action or call another function, execute another function. So this is the most important part. Okay. So after we finish, then we need to release the resources. If we don't release it, it costs that long. Here's the reason. Because other process, okay, as the process, okay, they are still waiting in the like they're waiting forever, waiting because you never release it. Let's say if you forgot to implement this part, okay, because from the solution right here, we just talk about the resources to get it, okay, granted, but we never tell about like to prevent the like deadlock or somehow like or safety check. For the deadlock, that means that we make sure we have to release the resources. So if I didn't release it, it causes a problem. So either P1, P2, or P3, P4 later, no matter how many process grant the resources. If we never release it, other resources are waiting there. Okay, we're waiting forever. Okay, so when they're forever, because also if we have multiple resources, like right here in the example, if we have multiple, okay, if we relied on others release the resources, but you never able to like get it because you are kept like for waiting, then it costs that long. Okay, so that's why we need to writing script to prevent the situation happen like this. Okay. Later I will give you some assignment. You need to writing your pseudocode. Okay, to writing it. And for practice, you can try not to look at the solution. Then you can think about it. How can you write by yourself? And then based on what I'm saying, okay, how can you be improve? Because in this situation, okay, for question 1, so is I giving you the beginnings, how can we checking the available resources, and then later when I tell you how can we prevent the deadlock, then we need to like change the source code to this way. Okay, so you can using for the multi-processes and they want to implement this the change modify it. Okay, so change the source code, then you can try to test it, or you can write a sudo code like this one. I can accept this one like to 7. So you are not going to tell me like P1, P2 in this way, because when I read your source code like this, okay, so we turn the input process number like this, I don't care, and then I return the process number. Okay, let's say the process number. Okay, so if you are waiting in this way, will be fine. Okay, because I will know. Okay, first, when we call the fork function, we have system code. We maybe create multiple processes. Okay, I don't care like from 1 to 2, 3 to n. Okay, it doesn't matter. And all of this process will execute this first instruction. Okay, we are checking, do we have available resources or not? Okay, if no, they are just kind of like in waiting, like keep checking. Okay, go back to the waiting in the queue. Okay, waiting for it, waiting for it. Okay, so we until one of it like gain the resources, then we can execute it. Okay, so right here, I didn't check. I need to check. Did I change the bottom one? Okay, RA2. So we need to make sure both of them, they should be true. Okay. Okay. True, true. So both of them, they are true condition. That means that we can access it. Then we can change to false. That means we need to doing protection, because they only this one we are assuming the situation is only one resources. Okay, so only one for each like RA1 and RA2. So I have to get both of them, then we can execute. So after we get it, so we need to change the false. If we have the P2, P3, Pn, it doesn't matter. So we stay on this while loop and checking. So if even I change one false, that means we can execute, it'll be fine. And then once we get both of them, they're true, okay, then we can execute it. So we turn the resource 1 and resource 2 be false, then we can execute certain function that we expected. And after we finish the function, then we can change release it then. Okay, release, then we can change to false. Then we can execute. Okay, this one just like saying, okay, this one is the PN say the or we could say the PID. So I think try not to confuse it. Okay, so like this. Okay, so we know which process. Okay, going to get this right to access to the resources. Okay, so after you finish, then you need to release it. If you don't release it, it costs deadlock. Okay, of course we do have a safety check. So this function is like checking if it's available or not, and then um, I just keep this part. I let you know earlier, but we will come back. Okay, after I finish the lecture, also later about the bankers algorithm. So that one is like one of the algorithm to for scheduling somehow. But we'll come back to this part. Okay, but for your practice, you can look at question 1, 2, and then try to make it more perfect. So you should able to write a program like this way. Okay, just thinking this way. Try not to look at the solution and try to do it by yourself. If you can like write something like this, you look it's really simple. Okay, but how can you prevent? Because this one I just saying 2 process. If I change it, so if I ask you, if I have 3 process with like 2 resources, 3 resources, how can you going to handle it? Okay, how can we using a while loops? And then we have multiple resources. How can we do that? So you do need to think about it. And so far, this one is the really quick exercise like for your lab. Okay, so you can study for it. So you can check and then try your best to like understood like what's the logic in behind. And mainly we try to prevent is the deadlock in this moment, and then have an idea of safety check. But of course later when I cover different algorithm, we will talk about like how can we prevent the deadlock, and also the the safety have a safety check. Okay, in this moment, just let you like feel how it really working. Okay, and I do have some question in this format. Okay, to ask you in the assignment. So I wish you're able to get it. Okay, and that's it. Thank you.